Okay, well, let's take a look at this question. Which choice below is another way to write the following? Now, notice, you may want to count as I'm writing this. 3 3s, 4, 5, 6, 7, 8, 9. I just learned how to count, so that was fun for me. Okay, so we want to know which one of these choices represents this. Is it 9 times 3? 3 to the 9th power? Or 9 to the 3rd power? Okay, well, let's think about this. This is really repeated addition. Right? We have the same number that we're adding 9 times. So let's think about what this means. Well, repeated addition is the same thing as multiplication, because this means 9 threes. That's what 9 times 3 means. It means I have 9 threes. So 9 times 3 is your correct answer for that problem. Okay, we'll talk more about this later, but 9 times 3 is correct because repeated addition is multiplication. So that's extremely important that you understand that. I have to tell you, we talked about addition and then we talked about subtraction, but a lot of times I like to teach addition and then multiplication, because if you can add, you can multiply. Because this just means I'm adding the same number over and over and over and over again, okay, which is what I was doing in that problem. Okay, let's talk about commutative and associative. Let's think about if multiplication is commutative and associative, or associative. Maybe it's just one of those. So let's take a peek at that possibility. Let's remember what commutative means. Commutative property means to change the order, because remember, commute means to go back and forth. So let's take a look at 14 times 15. This is a math example. Oh, let me put this little dot here. Let's talk about this for a minute. That's a raised dot. Okay, that raised dot is another way to write multiplication. In fact, before we continue, let's look at some of the other ways you can write multiplication. You're probably just used to using that little x, like 14 times 15. But in algebra, you got to be careful of that little x because it gets confused with the variable x. So let's take a look at the different ways we can write it. Let's start with something like 9 times 3. That's what you're used to saying. Well, you could also do 9 raised dot 3. That also means 9 times 3. Then you have parentheses, which is called the grouping symbol. You can do 9 times 3. I know that's multiplication because there's nothing between the 9 and the parentheses. But you can also have them both in. I call this overuse of parentheses. Okay, but you can have them both in parentheses. Or you could even make it look like this, which is, oops, that's the first one, sorry. You could even make it look like this if you wanted to. Most people don't, but that's acceptable because there's no symbol between them. It means multiplication, okay? But later on when we get to variables, what you could have going on, let's say you want to say 2 times a, we very rarely write that because, again, that looks like 2xa, okay? So we very rarely use that, but we could write 2a, and again, there's no sign between the 2 and the a. That tells us it's multiplication. Or you can do the parentheses, 2 parentheses a. There's so many ways you can write this. Or 2a, or even 2a. It gets crazy, but probably what you'd see mostly is this. Okay, 2 followed by the a, no symbol. Obviously, if you think about that, you can't do that with just numbers. That does not mean 2 times 7. That means 27. So if you have just 2 numbers, you're going to have to do something, either a dot or a parentheses or something to show that. So these are the different ways you can write multiplication. You can use a raised dot. You can use a parentheses. Very rarely are you now going to see the x because we're going to deal with algebra problems. Okay, back to this whole idea of commutative and associative with multiplication. Okay, if we start with 14 times 15, if we want to know if that's commutative, well, that means that has to be equal to 15 times 14. And they are the same things. It doesn't matter if we write 14 times 15 or if we write 15 times 14. So multiplication is commutative, which is kind of cool. because you're going to see lots of different ways we can show this in different problems. Okay. Now, in algebra, we would say this then. In algebra, we'd say let A and B be real numbers. So if that's A and that's B, we would say A times B equals B times A. So again, multiplication is commutative. So far we know addition is commutative and multiplication is commutative. That makes total sense because addition and multiplication are related. Multiplication is repeated addition. So if it works in addition, it must work in multiplication. So it kind of makes sense. Now let's deal with the whole idea of associative property. Okay, associative property means your order stays the same, but your grouping, who you associate with, changes. So let's take a look at whether or not it's associative. So let's take a look at 5, 6, 7. Let's not change the order at all. And let's do 5, 6, 7 equals 5, 6, 7. So we didn't change the order, but now let's change the grouping. So it doesn't really matter who you start grouping with, but if you started with the grouping here, where the 6 hangs with the 7, let's let the 6 hang with the 5. Well, this is going to be the same. Watch, I can prove it to you. This is 5 times 42. And this is 30 times 7. And we can do this problem. This is 210, but this is also 210. So that is a true statement. So notice it is also associative. So multiplication is associative. So we can change the grouping. I can write that in symbols if I'd like. If A, B, and C are any real number, let me kind of use a different color so you can see this. If 5 is A, and 6 is B, and 7 is C, we have A times the quantity, B times C, keeping our letters the same. 5 is A, 6 is B, let me raise that up a little. 7 is C, we have that. So again, we kept the order, A, B, C, but we just switched the grouping. So B is hanging with C, here B is hanging with A. So multiplication is associative, and you can write it in math, or you can write it in symbols. Okay, the next thing we want to talk about is the identity element. Well, if you recall, the identity element of addition was 0. Let's see if we can recall why it was 0. Identity, think about that whole mirror thing going on. If you look in a mirror, you get back who you started with, sometimes unfortunately, but regardless. Okay, so 7 plus blank equals 7. You get back where you started. Remember, that was 0. That made the identity element for addition 0. Well, now, if we want an identity element for multiplication, that means 7 times some number is going to give me 7. Well, that number has to be a 1. So that makes 1 the identity element for multiplication. Just if you remember what it means to be an identity element, you probably won't have to memorize that. Okay. And those properties are summarized in your workbook. Let's look at these numbers, the 5, 3, and a 2. The 5, 3, and the 2 are all attached by multiplication. That makes them called factors, because factors are attached by multiplication. Now, it looks really easy here, and it is, but later on when we get into the algebra, it becomes extremely important, okay? We're going to talk about all the different ways we can multiply this. Because we said multiplication was commutative and associative, we can kind of fool around with these numbers. So if I wanted to, I could do 5 times 3 is 15, times 2 is 30. I could do that. Multiply the first two, and then multiply the answer by my next. Remember, we got 30. Or if I didn't want to do it that way, if I wanted multiply the last two. First, 3 times 2 is 6. 6 times 5 is 30. I could do that. It doesn't matter because, again, it's commutative and associative. Okay. Or if I wanted to, I could even go, well, I can make a 10 here. 5 times 2 is 10. 10 times 3 is 30. I can multiply it any way I want. So what you have to remember about multiplication, what makes it so cool, is that you can multiply any two factors you want first, and then you answer by your next one. But understand what I said, your answer by your next one. So if you're multiplying more than two factors, multiply any two together, and then you answer by your next one. Okay, it's kind of, I know you don't think that's valuable now, but it truly will be valuable later. Okay, now I want to make a deal with you. Here's the deal. Let's say you're allowed to pick any baseball team you want, and you can follow them the whole season. Okay, and during the whole season, you get to write down what they score at the end of the game, how many runs they scored. At the end of the season, you can either have the product. Product means to multiply. You can either have the product of what they scored or the sum. Here's what I mean. Let's say you're covering a team, and let's say they scored 3 runs the first game, 2 runs the second game, 5 runs the third game, 1 run the fourth game, and so on. At the end of the season, you get to either add this all up and have their sum in money. So right now, so far, you'd have $11. Or you can have the product of their runs in money. So I'd multiply 3 times 2 is 6, times 5 is 30, times 1 is still 30. So you can either have their sum or their product in money. Remember, sum means to add and product means to multiply. Now also assume this, so you don't play with me. Assume that some money is better than none and you are desperate for money. Which would you take? Really think about that, because I know what you're going to jump at. Most people jump at multiplication. Okay, well, let's take a team, for instance. Let's say you got a team and they score 3, 2, 5, 1, 0, 3. Okay, look, 33. Almost like a football game, okay? What happens here? Well, you had all this money going on, but all of a sudden now you have 0, because any number times 0 is 0. Even if you score 33, the next game you still have nothing. Where at least if you have the sum, you would still have some money. My brother, every Christmas, would say, hey, Maria, don't worry. I'll get you double this year what I got you for last year. Here's the problem. You know what he got me last year? Nothing. So double nothing is still nothing. Okay? So you got to be really careful, because when you multiply with 0, you're going to still get 0 back. So that's one of the properties of multiplication that we want to talk about. The other one is this one right here that we really talked about a second ago. If I multiplied 3 times 2 is 6, times 5 is 30, times this 1, I still get 30. So when you multiply by 1, it doesn't change your answer. When you multiply by 0, you always get 0. So that's the multiplication properties of 0 and multiplication properties of 1. So let's kind of summarize them. And these are in your workbook. Okay. Of 0. Of 1. So the multiplication property of 0 says that any number times 0 is 0. So if I have, let's say, the number 3, 3 times 0 is 0. That's my math example. But in algebra, or arithmetic example if you want to say, in algebra, I can let a be any real number. That would be a times 0 is 0. Now I have to tell you, generally you wouldn't say a times 0. Generally the 0 would go first. The number usually goes in front of the letter in algebra. So it would be 0 times a is 0. But notice these are the same thing because it's commutative. Okay, multiplication is commutative. The property of 1 tells me that any number times 1 is that same number. So for instance, if I have 3 times 1 is 3, okay, that means that a times 1 is a. But again, we generally put the number in front of the variable. So that would be 1a is the same as a. 1 times a is the same as a, which makes sense. If I have 1 a's, I have an a. So it's the same thing. 1 times a is a. So that's the multiplication property of 0 and of 1. All right, let's calculate using mental math. What we mean by mental math is to do it kind of in your head. So these problems are in your workbook, and the first problem is 9,841 times, remember that dot, raised dot means multiplication, times 0 times 765. So we want to do this problem, but we want to kind of do this one in our head. Okay, number 2, the second problem is 4 times 50 times 1. 4 times 50 times 1. So stop the video for a second, do this very quickly, and then come back and we'll talk about your answer. Okay, so let's look at these two problems, and let's do a little mental math. Again, it means to do these in your head. So let's just take a second to do that. If you do that, I hope you notice that there's a 0 here, and anything times 0 is 0, so that would be 0, even though there's huge numbers there. Here, there's a 1 here, so we can almost disregard that because anything times 1 is what it was. So we just have to worry about 4 times 50. 4 times 50 is 200, so our answer here is 200. So here's the multiplication property of 1. Here's the multiplication property of 0 in action. Okay, I know you're not allowed to use a calculator, but I just want to use this calculator for pattern seeking. So we're going to do these problems on a calculator. Okay, so I got my handy-dandy little iPhone calculator. That's pretty cool. Anyway, all right, here we go. I'm going to steal this. I borrowed it. I'm going to steal it. Okay, and 7 times 10 is 70. And 7 times 100 is 700, and 7 times 1,000 is 7,000. And now let's go to 18 times 10. Oh, it turned over. Okay. 18 times 10 is 180. 18 times 100 is 1,800. Do you see a pattern? I'm hoping you see a pattern soon. Okay, 18, because I'm going to put the calculator down in a minute. Okay, 18 times 1,000 is 18,000. Okay, so I'm hoping you see a pattern. Let's look for it for a second. Okay, so 7 times 10 is 70, 1010. 18 times 10 is 180, 1010. Okay, 145 times 10. You want to take a stab in the dark there? Well, 1010. Okay? Now, I want you to also notice what's truly going on. All that's really happening is the 7 times the 1 is being multiplied, and you're adding the 0. Okay? That's going to come in handy in a minute, whether you know it or not. Okay, 2 zeros, 2 zeros. 7 times 1 is 7, 2 zeros. 18 times 1 is 18, 2 zeros. 145 times 100. Well, 2 zeros give me 2 zeros, so 14500, which is 14,500. Okay? Same thing here. 3 zeros, 3 zeros. 3 zeros, 3 zeros. So again, 145 times, oops, sorry, supposed to put the answer there. Apologize. 145 times 1,000. We have 3 zeros. We got to put in 3 zeros. These are called powers of 10. This 10, 100, 1,000. They're called powers of 10. If you multiply by powers of 10 like this, all you do is add that many zeros to your whole or natural numbers. That's what happens when you multiply a whole or natural number by a power of 10. You just take the number you have and add that as many zeros as there are in your power of 10. So that's how you multiply by a power of 10. It's a pretty kind of nifty trick. Let's see if that helps us answer other problems. And that chart was in your workbook. Okay, so let's take a look and see if that helps us answer any of this. 7 times 10,000. Okay, 18 times 10,000. And 145 times 10,000. Oops. 145. Let's fix that. 145 times 10,000. Looking at this, if we do the same thing, the same little pattern, we have 7 times 1, that's 7. 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. We get 70,000. Here, 18 times 1, 18. 1, 2, 3, 4 zeros. 145 times 10,000. 1, 2, 3, 4 zeros. 1, 2, 3, 4. We get 1,450,000, which just happens to be the amount of money I have in my pocket right now. No, only kidding. Okay, so that's how you multiply by a power of 10. Doesn't matter how many zeros there are here. You just keep putting in the zeros. All right, let's see if that helps us add, multiply anything else. What about this? What about 12 times 500? Now, I just want you to remember how we really said, what we really said was going on here. We said it was 145 times this 1 gave you the 145, and then we counted the zeros. If we do that same pattern, this is really pretty simple, because then we can take this 12 and multiply it by the 5, and we get 60, but now add the 2 zeros. So we get 6,000. Okay? So that's really kind of easy. Okay? Let's see if we can do another one. How about 7 times 3,000? 7 times 3,000. Again, we have this 7 times this 3. 7 times 3 is 21, and we add these 3 zeros, and we get 21,000. So it makes multiplying with a power of 10 really, really, really simple, okay, if you understand how it works. Okay, how about 7 times 43? Now, understand what we just said about these powers of 10. Okay, it's easy to multiply by a power of 10. Now, I want to show you something that you may never think of doing, but in actuality, it's very, very simple. Watch this. 7 times 43. Well, if that was 7 times 40, that would be nice. Well, what if we wrote 43 like this? That's 43. Why is this a good idea? Well, because it's easy to multiply by a number that ends in a 0. Okay? So if we do this, we can actually do this. We can actually go 7 times 40. 7 times 4 is 28. Put the 0 on. Plus 7 times 3, which is 21. So notice what I did. 7 times 4 is 28. There's the 0 for 280. 7 times 3 is 21. So now we just add these because there's an addition here. 280 plus 21 is 301. Kind of clever. Let's talk about that and let's check it. I can show you this is true if you don't believe me. If you're sitting there as a skeptic, I'll show it to you. Okay, this is 43 times 7. I can do this the long way. Okay. 7 times 3 is 21. Carry the 2. 7 times 4 is 28, plus 2 is 30. There's your 301. Now, I could do this. This isn't a very hard problem, but this is another way if you want to do this in your head. Some of you might be able to do that in your head. The older I get, the more I can't get all these numbers in my head at once. But I can do this pretty simply in my head, so this might be a good idea for some of you. Now, I want to talk about what this is called. Notice these little arrows here. Okay, that was a bad line probably. Let's try that again. All right, here we go. I'm going to rewrite this number, this problem, and show you this. I need you to understand that there's a couple things going on here. This is 7 times this whole quantity. What's inside here are terms. This is actually called multiplication over terms. That means there's multiplication outside and terms inside. Remember, terms are attached by plus or minus, so you got a plus here. Terms are attached by plus or minus, and you have multiplication over terms. Whenever you have multiplication over terms, you have something called the distributive property. Oh, new property, new property. Wish I had a little drum. Okay, we have the distributive property. Now, to be honest, if you were doing something called order of operations, you probably would do parentheses first, but I just want to show you this is a viable thing to do. And distributive property tells me if I have multiplication on the outside followed by terms on the inside, I can distribute that 7. So I can multiply what I just did was called distributing. Okay? But what is in here must be terms, so these must be connected by plus or minus. If that was a multiplication sign, I could not do that. It's got to be multiplication over terms, and I can do the distributive property. It's a cool property, and even cooler when we get to harder algebra problems. Right now, you're going, oh, I'd just rather multiply the long way. But the truth of the matter is, it becomes really, really a good thing to know. Okay, so let's take a look at this next problem, 23 times the quantity, 30 minus 4. Okay. First, let's talk about if we can do the distributive property or not. Well, we have multiplication outside, we have terms inside, so we can use the distributive property. Distributive property allows me to do this. Okay, 23 times 30. Well, 23 times 3 is 69. Put in the 0. 23 times 4, and this is going to be a minus now. You just drop the minus down. Okay, 23 times 4 is 92. Now, this is a little hard to do in your head, maybe, but 690, we know what 690 minus 90 is. It's 600. So take 2 more away, so it's 598. Okay, so that answer is 598. Now, here's the hard question, I think. What did you really multiply? What numbers were you really multiplying? The numbers that you were really multiplying, if you think about it, is 23 times 30 minus 4, 26. So 23 times 26 is 598. That's pretty cool, maybe. Just another way to multiply. So that might work out. Okay, let's look at another example. Let's look at 34 times the quantity 10 times 4. Okay, in this problem, we have to make sure we can use the distributive property if that's what our goal is here today. Okay, well, the problem is that it's got to be multiplication, which we have, but it's got to be over terms. Terms are attached by plus or minus. There are no terms here. So you cannot use the distributive property. No terms, no terms, no distribute. Okay, so you cannot use the distributive property here because there are no terms. Now, how do I do this problem? I would just have to do parentheses first. 10 times 4 is 40. So now I have 34 times 40. Well, now I can do this problem because I have a power of 10. It's not too bad. Okay, so I do 34 times 4. 34 times 4 is 136. And now with that 0 is 1360, 1,360. So that's the answer to that problem. The whole thing I needed you to understand is that there's no distributing here because there are no terms. So that's the important part about that problem. Okay, so you see that sometimes you can use distributive property if you have terms, and sometimes you cannot if you do not have terms. Now, there are a couple more problems in your notebook that I'm going to ask you to do. So I'm going to let you have a couple seconds to do that, and then we'll check your answers. Okay, so I hope you did okay on these problems, but let's take a look. All right, I can use the distributive property here because we have multiplication over terms. Remember, terms are separated by a plus or minus, so there's your plus sign. And by the way, all these examples have only 2 terms inside the parentheses, but they could be as many terms inside as you want. It does not really matter. Okay, so we're going to distribute 7 times 20. Well, 7 times 20, since 7 times 2 is 14, here's your 0. That's 140. And then plus, because there's a plus there, 7 times 5 is 35. That's 175. Now, that's awesome, and that was pretty easy. But the main thing you have to understand is what problem you really did here. So you have to understand that what you really multiplied is the 7 times what's in here, which is 25. So this is really the answer to 25 times 7. Okay? That's really the answer to that. So 175 is our answer, but you have to know, be aware that you multiplied 25 times 7. Okay, so let's take a look at this one. In this one, again, there are terms inside, multiplication outside, so you can do the distributive property. We distribute the first term, and that's 11 times 100. Well, 11 times 1 is 11. There are 2 zeros there, so we write them down, and then bring the minus down. 11 times 7 is 77. So that's 1100 minus 77 is 1023. So our answer there is 1023, but again, know what you've multiplied. You multiplied 11 times whatever this is, and 100 minus 7 is 93. So you've actually multiplied 93 times 11, okay? Let's look at the last question. Again, you can use distributive property because you have multiplication over terms. 24 times 2 is 48. Bring the 0 down. The plus because there's a plus there, so we did that. Now 24 times 5 is 120, and 480 plus 120 is 600, okay? You might need a pencil to do that, pencil and paper to do that. You can do it off to the side, whatever you want. But let's notice what you actually multiplied, and what you actually multiplied is 24 times 25. So here you actually multiplied 11 times 93. And here you actually multiplied 24 times 25. And you did it all by using the distributive property. I'm not saying you have to do that, but just be aware that you can. Okay, you can do that. Okay, so that takes care of, hopefully for now, the distributive property. Now let's just do some straightforward multiplying, just to kind of get you ready. Here's the deal. I know that you've been probably using anything you can to multiply, subtract, add, you know, wherever you can find a calculator. You've probably used a calculator. You're not allowed to use calculators here. You really want to be aware and have some kind of number sense. That's why you're not allowed to use a calculator. But what you might want to do, there are 100 websites you can go to look how to multiply or add, to play games with it, to get really familiar with that. Ask your instructor because they'll give you some ideas. But let's look at the following problems. All right, it's time to do some regular multiplication. Okay, 47 times 63, we'll start with that. Okay, so I know you know how to multiply, but you know what? Let me make this a little smaller so you know that doesn't get in the way for you. Okay, here we go. We're going to take the 3, multiply it by each digit, then do the same thing with the 6. 3 times 7 is 21. Carry the 2. 3 times 4 is 12, plus 2 is 14. Remember that little placeholder? Am I dating myself, I think? I think I'm dating myself by doing that. Most people don't use placeholders. I like a placeholder, so you might want to use a placeholder. Now, here's the other thing you might want to do. This is the stuff you used before when you carried. You either may want to cross it out or erase it so that you don't confuse it with what you carry now. I see a lot of people doing that. That's up to you. So you might want to cross it out and go 6 times 7, that's 42. Carry the 4. 6 times 4 is 24, plus 4 is 28. So now that you have that, now we're going to add that. And notice we have to add everything in the right place. So the ones place gets added, the tens, the hundreds, the thousands. We get 1, we get 6, we get 9, we get 2. 2,961. And that's, if you recall, how to multiply. And that's pretty simple. Okay, now you're going to take a second to do the next one. Of course, I left you the hard one, but we'll check your answer when you come back. Okay, so let's take a look at what you got here. 3 times 6 is 18, carry the 1. 3 times 3 is 9, plus 1 is 10, carry the 1. 3 times 2 is 6, plus 1 is 7. So that's what you get when you multiply to 3. You might want to cross these out or erase them, whatever makes you happy. Remember the 0 placeholder. 2 times 6 is 12, carry the 1. 2 times 3 is 6, plus 1 is 7. 2 times 2 is 4. Okay, now I need 2 zeros. So first 1 and then 2. Okay, I need 2 zeros. Again, I might want to cross that out. And now I just have to take the 1. Well, 1's easy. I'm glad I got a 1. 1 times this is 6. 1 times this is 3. 1 times 2 is 2. So we got 6. I'm going to erase because I need some more space here. So that's 1 times 6 is 6. 1 times 3 is 3. 1 times 2 is 2. And again, adding up, making sure I stay aligned. we have 8, we have 2, 14 plus 6 is 20. That's 9, we have 2, so it's 29,028. And that's just straightforward multiplying, and that's all we're asking you to do there. Okay, before we do the rest of the problems that we want to do, I want to take a look at some keywords for multiplication. Okay, so some words that tell us to multiply. Okay, so keywords. For multiplication, example, symbol. Okay, this is in your workbook as well, so you may just want to follow along. Okay, we have multiply. That's so obvious, I don't want to write it down, multiply. Multiply tells you to multiply. That's kind of obvious. We have product. Remember, product is the answer to a multiplication problem. And we have times, another one that doesn't come up a whole lot in algebra, times. We have other words as well that we'll see as we go on, things like double. Double means twice as much. So if you want to double a number, it means to multiply by 2. Or triple means to multiply a number by 3. Or twice means to multiply a number by 2. So those words we'll go over, but they haven't really come up yet. Okay, so multiply 7 by 5. That would be 7 times 5. Now you can either use a dot, or I could use a parentheses, whatever makes you happy. I would stay away from the x from now on. I would just stay away from it. The product of 7 and 5. Okay, now here's that and word again. Remember, and does not mean to add. And just tells you where to put the operation symbol. Well, product means to multiply. That's where the multiplication symbol goes. So of 7 and 5. That's the way that looks. And last but not least, 7 times 5. Obviously, that means that. And again, it doesn't really matter if you go 7 times 5 or 5 times 7, because multiplication is commutative. However, I would leave it this way, because remember the phrase less than and the word from, they switch the order. I would only switch the order when I'm using those words for subtraction. Okay, well, as you could take a look at your workbook now, because right after this you have some problems that we're going to go through that are word problems that most people don't really like to look at. So we're going to do that together. So let's look at the first problem there. Okay. The first problem is about a printer. It says, okay, a computer printer can print 16 pages per minute. And you want to know how many pages can it print in 45 minutes. Pages in 45 minutes. Now sometimes, I know this is silly, but sometimes it's a good idea to write yourself a little diagram almost. If I have 16 pages per minute, that means every minute it's going to print 16 pages. How many pages in 45 minutes? Well, think about your minutes. You got minute 1, minute 2, minute 3. Don't worry, I'm not going all the way up to 45. Don't freak out about this. Okay, you got all those minutes, 45 minutes, and it's 16 pages. So 16 the first minute, 16 the second minute, 16 the third. So you have all these 16s, and you have 45 of them. So the fact that it's 16 pages every minute, so it's 16 the first minute, 16 the second, the third, all the way up to 45, tells me it's repeated addition, and repeated addition is multiplication. So we have to take this 16 and multiply it by 45. So if we do that, we get 5 times 6 is 30, carry to 3. 5 times 1 is 5, plus 3 is 8. 0 for placeholder. 4 times 6 is 24, carry to 2. 4 times 1 is 4, plus 2 is 6. That's 720 pages. Now that's a good answer. 720 is a good answer, but a better answer to make sure you absolutely understand what we're saying is 720 pages in 45 minutes, because that's what's really going on. So that's probably the best answer you can give, because that absolutely says that you understand what this problem means. So that's the printer problem. Okay, and this next problem, Ken bought DVDs and CDs. Okay, and he bought DVDs cost $11 each, and CDs cost $9 each. Okay, he bought 14 DVDs, and he bought 8 CDs. And you want to know the total cost. Well, he bought 14 of these, each at $11. That's repeated addition. 11 plus 11 plus 11 plus 11, 14 times. So I have to multiply here. And he bought 8 of these. Again, repeated addition, so I have to multiply there. So for the DVDs, I have to take 14 times 11. And I'm going to show you a really cool trick. You ready? I shouldn't be showing you guys this, but I'm going to show you anyway, because I could do this the long way. And I will in a minute, but here's a really cool trick for multiplying by 11. You want to see it? It's awesome. Here's the 11 rule. 1 times 1 is 1, straight down. 4 times 1 is 4, straight down. Add these two numbers up, 4 plus 1, you get 5. So 14 times 11 is 154. That's so cool. Watch, it'll work again. Watch, this has nothing to do with this problem, but watch, this is just too cool to, like, spare. Okay, ready? 23 times 11. Bring the 2 down, bring the 3 down, add these. Oh, yeah, 253. Awesome. All right, watch this. 72 times 11. I'm not going to be able to stop. I feel it. Okay, so 7, 2, add them up. Oh, yeah, 792. Awesome. Cool. That's so cool, I can't stand it. All right, but that has nothing to do with this. Okay, but you learned that. That's nice. Okay, I can do this the long way, and I will for you, because I don't want to cheat you. The long way would be 1 times 4 is 4. 1 times 1 is 1. Carry the 0 here. Bring the 0 down as a placeholder. 1 times 4 is 4. 1 times 1 is 1. This would be 4. This would be 5. This would be 154. Yep, said that already, but that's okay. CDs, that's an easy one. $9 times $8. I'm sorry, $9 times 8 CDs. That's $72. But I want the total cost, so now I have a little addition going on. 154 plus 72. That's 6, that's 12, that's $226. So his total cost is $226. Okay? So that's how much Ken spent on DVD. He's nuts. Anyway, on DVDs and CDs. Okay, let's take multiplication and apply it a little bit. Okay, one of the things we could do is take a look at this next problem. It says Rosie wants to carpet her room, and she wants to know how much carpet she needs. Well, let's draw her room. Okay, this is not really her room, but, you know, it's a rectangle. And it's 11 feet by 8 feet. And that one dashed line means feet. Okay, so here's the deal. She wants to carpet her room. Carpeting her room means she wants the inside of her room done. That is area, not perimeter. So we have to first understand that. Second thing we need to understand is what area really means. It means that I want to take, well, rectangles that are 1 foot on each side. So that means that it covers 1 square foot of area, and I want to fill this up, and I want to know how many little rectangles it's going to take to get in here. Well, here's the deal. If this is 11 across, that means I can fit 11, all the same, yeah, I'm really good at this. All the same size across, there's going to be 11, and if this is 8, that means they're going to go 8 down. So we want to know how many that's going to be. Well, that's simply 11 times 8, because area of a rectangle is length times width, which you'll see as area equals LW. And to be honest, it doesn't matter what you call the length and what you call the width. You know why? Because it's commutative. So I like to call the width this piece because that's how wide my mouth might open. Okay, so the length is 11 times the width, which is 8. And this is 88, and it becomes square feet. Okay, square feet. Let me write down square since that's the first time you've seen that. 88 square be able to explain later why that's really square feet. But when you take a square or any other, or a different kind of quadrilateral, you're really talking about little squares that go in there if it's a square. So that's one of the reasons it's square feet. So she needs 88 square feet of carpeting to cover her room. And that's the end of multiplication. I hope you learned something, and I hope you liked that 11 little trick. And next time we'll do division of whole numbers.